everybody. I'm Justin from Toolpath Labs. I'm the CTO, and today I'm here to record an episode of Chips and Tips with Jim Belosic. Jim, I'll give you a minute to introduce yourself.
Yeah, thanks for having me. I'm Jim Belosic from SendCutSend. Started SendCutSend because I needed car parts. So built it kind of for personal reasons, and 7 years later, here we are. It's turned into a crazy beast. It was supposed to be a hobby, and now it's my life.
Your whole life, I'm guessing.
Yeah, and I grabbed my wife's life too.
Oh, wow.
Yeah, she's president of the company. We work together every day. Help my kids work here.
So she's
school.
Your boss at work and at home?
She's the only one who can fire me.
Right.
Yeah.
Okay.
Yeah. So I'm nice to her though.
Okay. If you want to know a little bit more about Jim's background, he went into a huge amount of detail on Within Tolerance, episode 243. So definitely go check that out. We're not going to go too much into that, although anything's on the table for you, Jim. But I'm actually out here visiting to talk about you guys using Toolpath to help power some of your new machining stuff that you're coming out with. So why don't you tell us a little bit about that?
I think CNC machining is where I wanted to start, 7 years ago. But it's an incredibly huge challenge, as every machinist who's listening to this. I know nothing about machining. I'm learning every single day. But it's so incredibly challenging, especially when you compare it to sheet metal. So that's where we started. I was like, well, I'm not good enough at machining, and I'm not a good enough designer. I don't know how to program, and I can't afford these machines. So why don't we start with a laser? Let's start with 2D and figure that out. So, over time, we got pretty good at doing a lot of complexity and, kind of building our infrastructure and our ecosystem for sheet metal. And we kind of felt like it was time to explore something different. Sheet metal is great. I think we still have another 10 years of innovation that we could do on the sheet metal side. But I tend to get bored when things start to, plateau or get easy. If I'm not putting out fires every day, literal or figurative, then I'm always chasing something new. So a bunch of things started to kind of coalesce, I guess, which is the CNC machines like 5-axis got really, really good recently. The design software has gotten really, really good. Innovations in 3D printing and stuff have encouraged like a whole new generation of designers to come out and try and make stuff. So we have demand on,
to the ever-loving frustration of machinists.
Yes, good Lord. Yeah, it's terrible. I want to design a 3D printer that can only print machinable stuff. Just force it upon children. So anyway, all of these things have kind of been happening over the last, 4 or 5 years. And our team started getting smart around, how we could handle 3-dimensional geometry. And then, tools like Toolpath kind of said, oh shit, there's guys who are trying to solve this. Maybe we can collaborate. Maybe we can, attack this in a way that is on brand for SendCutSend. And meets the needs of a lot of our customers.
So one of the really interesting things I think about the way you're launching the business is no prints whatsoever, right?
Yeah.
And so forever in this industry, we've had a part come in as usually actually started as a 2D drawing, and then the machinist would have to make the 3D drawing. Now we get a 3D drawing plus a print, or a 3D model plus a print. So you're going to take no drawings, right?
Correct.
And everything's going to be plus or minus 5 thou. It's just general tolerance. You'll do some tapping, it sounds like?
Yes.
Okay. But a limited amount, right? Not like every tap under the sun.
Yeah. So, when I first said, hey, we're going into machining, the first questions that people asked me was like, oh, how are you going to handle, prints? How are you going to, are you going to use AI to, read the dimensions and the tolerances? And I was like, no, we're not going to take prints. And everyone freaked out. They're like, how am I going to get my shit made? The thing is we've made over 50 million parts in sheet metal, and we've used prints 0 times. So are we a fit for everyone? No, but, we try and be the In-N-Out burger model where our menu is tiny, but it's good and fast and cheap. So we're a great fit for a lot of people who don't have access to machining right now. Guys in their garage, small businesses, people who just need, as you say, a part-shaped object.
Right. Yeah.
So that's really what we do. We do that in sheet metal too. We have customers where we're not a good fit because they need a tolerance that we can't hit, or they need an alloy that we don't offer, or they need a finish that we don't provide. And that's fine. There's a lot of shops that can do that work really, really well. But there's also a lot of guys out there who just need something in their hands, tomorrow.
Right.
And that's where we fit. So we're trying to do that same thing in machining. That's why we're investing in really, really good machines that can hit good tolerances, all the time. We're being really smart in our software. We're smart in our process. And
I will say,
I think it's going to work.
It's wild to just be here while they're dropping off 3 MAMs, like right now.
Yeah.
It's just wild.
I haven't even seen them. Like, actually, I don't like watching machine landings.
Right. It's scary.
Because it gives you a little pucker. But yeah, no, we're doing it. We're growing right now.
Fun side story. My first machine that we bought for Toolpath was a small Sile X7. We still have it. My driveway has about a 25-degree angle. And getting it in, they didn't freak me out that much. But when we took it out to move it into our actual shop, man, I almost had a panic attack watching the riggers like bouncing it on the forks and stuff. It was not for the faint of heart.
Yeah. Pro tip is leave to go get the riggers donuts and then come back.
Right.
Don't watch them move the machine.
Right. Yeah. Okay. So part-shaped objects. I really like this idea a lot, but I think it's interesting if we like wind the clock way back into like the 60s, right? Went to the moon and we did it all with like hand fabricated stuff and like brazing tubes and like Bridgeports, like dudes on Bridgeports, right? And if you ask a dude on a Bridgeport to hold a thou on pretty much anything, right? Like that's a bad day for that guy. He's pretty grumpy. And so the technology has advanced so far that I actually know a number of shops that like either get a print and ignore it or work with customers pretty regularly and don't get a print anymore. They'll just apply a blanket tolerance. And maybe it's tighter than 5 thou. But I think we're at this really interesting moment where the machines have advanced so far now, and the tooling is another thing, like really good tooling, really good holders. It's cool that you guys invested in like RegoFix and stuff. Taking all those variables out means that you can hit, if you're careful, you can hit tolerances like way within 5 thou. And obviously you're not going to guarantee that. But I think it's interesting to play with that idea.
Well, it's a double-edged sword though, because the machines have gotten so good, tools have got so good, the programming has got so good that now the expectation is, oh, I can just design it with +0, -1,
right? And
that's what I'm going to get. And it's I blame a lot of the machine salesmen too, because they'll be like, no, the repeatability is 5 microns. And you're like, yes, in a like lab situation, but designers and mechanical engineers and whatever will say, well, that's what the machine can do, so that's how I'm going to design it. What we do really well is kind of bridge that gap and say, hey, yeah, there's things that are possible, and then there's things that we actually want to do. And if you want to use us, like, here's our guidelines. Here's how to make yourself a better designer so that you can work not only with us, but probably with other machinists, other sheet metal companies. If you can get a part to run through SendCutSend and sheet metal, you can send that to any shop, in the world, and it'll work. So we want to kind of do that same thing with machining. Like I said, we're not going to be a perfect fit. If you're trying to send something, in flight that has to hit this crazy tolerance because it's going to be at cryogenic temperatures or something like that. No, there's thousands of shops that do that kind of work. But if you're trying to make an alternator bracket for this weird engine swap that you did, SendCutSend is going to be a great option.
We wrestle with this problem from a different perspective at Toolpath because we have to analyze the geometry and decide if it's machinable. Right. And so there's a lot of sort of as modeled and sort of a wink and a nod. Everybody understands. So chamfers are sort of the canonical offender, chamfer into like a wall or something. Pretty much everybody understands that I'm not going to chamfer it that way. It's going to stop short of the wall and everybody's just good with it. But we have to somehow inform the Toolpath software that that's okay. So it's cool to collaborate with you on that. What other kinds of features do you anticipate having to tell people like you're going to get something a little bit different?
Oh, everything. So what we've learned, after seeing millions and millions and millions of drawings, our customers are endlessly creative. And, and every time we think that we've like patched up a hole, they find a new one, or they create a new one. So, early on in sheet metal, our pricing algorithm was heavily based on overall square inch size. Mm-hmm. And some profile geometry or whatever. But the inside of that part, we didn't really pay much attention to. We were just dumb. And then people started uploading geometry that was like, a crazy mesh or something, or like it looked like lace. And all of a sudden our machine time spiked through the roof. So we're like, oh, okay, let's close this gap. And then as soon as we would do that, then they would find some other shape that was insane for us. There was, it's like a spiral shape. And if you pull it, it makes a Christmas tree kind of thing. So then we figured out, people were like, oh, I can do this crazy geometry. It makes these things really neat. But then it would break our machines because the material would stress relieve and pop up and the machines would collide with it. And so we're like, okay, we have to deny that geometry. So year one was like game of whack-a-mole. You're just like constantly plugging holes and saying no to stuff. And then year two, like you're doing a little less. And then, year 10, we'll do it occasionally, but we're still going to have it. So when it comes to machining, the challenges are just going to be like, can we even attempt to make it? Again, those 3D printer guys, like if you're listening, I love you, but just go spend some time in front of a mill for a little bit.
Right.
We've seen geometry that has like hollow internal voids that no tool could get, but you could do that in 3D printing. Or like undercuts, or, we were talking about like dovetails and T-slots and stuff like that. Yes, there's tools that you can purchase in order to do that. But going back with our in and out mentality, I have to have a small menu. I can't serve everybody. I can only fit so many tools in that machine.
So you're going to be a car part manufacturer, right? That won't support O-rings.
No. Yeah, exactly. And, are we going to be able to produce like OEM type things, that are ultra complex for like a modern vehicle or something? And no, but alternator brackets or, engine mounts or, a transmission adapter or something like that. Yeah, no problem. And that's what we know too.
Right.
We're all, I think all of our executive team and our engineering team, they've all been on a gravel driveway on their back, underneath some like 70s muscle car, changing oil or working on it. We've all done that at some point. So that's really our core. That's what the problem that we're setting out to solve right now. But then as the years go by, we will get more and more advanced. So yeah, maybe one day we will be able to make that O-ring, or do that weird undercut or something like that. But day one, no.
That O-ring gasket or O-ring grooves have a special place in my heart because I missed one and it was at the worst possible time. Like the entire Toolpath team was at our very first ever onsite to like learn how to run machines. And I was like, just make this part. And then my guys came to me and were like, that there's a 10-degree in cut on this wall that I thought was a pocket. And it was a customer part. Like I had to have it shipped out, which was the worst idea ever. So identifying drafted surfaces and like O-rings and dovetails became like a thing we had to have at Toolpath because it had bit me so hard.
Yeah.
So hopefully we can help you guys head that off, and people will take that out of their designs when they send them to you.
Yeah, and it's one of those things where we log it, we learn, and we start to see like, hey, is that a once in a lifetime thing or is it a once a day thing? And the more frequent it is, the more apt we are to solve it. And we do that with sheet metal all the time. People will ask us for a certain tap or a certain PEM hardware or, different types of tooling for the brake or something. Some of it is just insane and no one will ever use it. And then some of it we're like, yeah, that's a great idea. How come we didn't do that years ago? So,
one of the things I'm really excited about is your philosophy on like training your customer to design parts that you can manufacture. And it's going to be a challenge for Toolpath to provide you the capability to provide that insight to your customer for your shop specifically. But, one of the early sort of catchphrases that I designed for Toolpath when we were playing around with how to bring it to market was that Toolpath would make peace between designers and machinists one part at a time. I don't know if you've ever like seen the angry machinist like with print crumpled up in their fists, like stomping up the stairs, ready to scream at me. But I've been on the receiving end of that, and now I've been the angry machinist. And one time I was both. I designed a part and it was horrible to machine, but I only figured it out later and I had to yell at myself. The idea that software can advance to the point where that you can close that DFM loop, right? Because like if an engineer had like a machinist sitting next to them and they were like pair programming, for lack of a better word, on how to build this part, like all the parts are like, do you really need that to be like, you just need these two things to mate together. You don't need a 1,000 parallelism, right? Like over 27 inches, like, come on, that right? Also, this part's really flexible. So when you bolt it all together, none of that matters anyway.
Yeah. But they're missing a lot of that education. You know,
Right.
The machinist has done 10 years behind that machine. And then the other guy has done 10 years behind that monitor.
Right.
And they both think that they're right. So yeah, bridging that gap is critical. It's something that we do all the time. There's what you can design and then what can be made. And often they're near the same.
Right.
But there has to be compromises. One of the things that we do really well is just work within constraints, and we expect our customers to work within, those constraints. We loosen them over time. But yeah, just really like, I hope that our legacy is that we made, a whole generation of better designers because we actually showed them how stuff is made. So, I'd love to have cameras on all of our machines. I'd love to, send someone a text message when, their billet goes into a vise and we're like, hey man, we're going to machine your stuff. Like watch what happens here. Once you see that a few times, when you go back to the design process, you can go, oh wait, I kind of remember how, the spindle, it came down and it would collide with that wall because the tool's not long enough. Like you don't see that in Fusion or SolidWorks or whatever. You're just drawing whatever the hell you want. Maybe that's a good feature that, Fusion should have is your stylus, like instead of the 3D Space Mouse, like it should just be a spindle.
Yeah. Right.
And you have to like move that around. But anyway, if we can communicate, here's what you designed, but here's what you're going to get. Are you cool with that? And here's why, then yeah, maybe the first time they order is like a little rocky, but by the time they order it 10 times, they're a pro.
Right. Yeah. So, humans are really good at pattern matching.
Yeah.
Really, really good at pattern matching. They're bad at doing repetitive tasks consistently, but they're good at pattern matching.
Yeah. Well, especially when they're under a deadline.
Right.
So a lot of our customers need stuff very, very quickly. So we pride ourselves in really short turnaround times. And it's amazing the type of compromises and patterns you can pick up when you need something in 2 days.
I've heard so many stories about a machinist like struggling to make a part to spec. And then they have to finally go to the engineer and be like, I just cannot hold this tolerance. The material's moving on me, or this wall is too thin, or there's no possible way to hold this thing you invented. Sorry. And the machinist, and then the person's like, oh, well, just make that thicker. Or like, I didn't care about that feature at all. It was like non-critical geometry. And for some reason we don't mark non-critical geometry on prints. Like we should.
Yeah.
So I think that'll be a really interesting aspect of how, like, if you guys give people the opportunity to mark either like a very small amount of critical geometry, or just say like, all of this is non-critical. I think that'll be a big advantage.
Yeah. Tell us what really matters. And then we'll work, outside of that. That'll be our perimeter, and we'll try and stay outside. But as long as you're cool with us, making some small modifications or compromises outside of that perimeter, then I think we're good to go. I've heard stories like that too, where like, oh my God, I can't hold this tolerance. And then the designer is like, oh, that's just the default. When I go to make a drawing,
like I auto dimensioned it. Yeah.
Yeah. They're like, oh, sorry, I had it out to 5 decimals. Like that's just the default or something like that. And you're like, for the love of God, please don't do that. But it's very common. It shows itself in a company where there's designers upstairs and machinists on the floor, and they can at least go upstairs and have those conversations. Where it really breaks down is when you're a designer, but then you're sending it off to a third party. You're sending it off to Xometry or Protolabs or something like that. And then there's almost no communication, because especially when you're using a broker, the broker has to talk to the machinist talks back to the broker goes back to there. So it's this crazy communication thing. I'm hoping that we can eliminate a lot of that and just go directly back to the customer and give them some education. I
think that's a really important topic to cover here. speed matters so much. And a lot of times, I used to do this sometimes when I would quote a part, I'd be like, okay, you want post-process, you want anodize, right? But you also probably want like one of these parts in your hand really quickly. So do you want me to send you one before I anodize it? And then like the rest of the 5-day lead time for the rest of the parts? I actually only had one customer take me up on it. But I would always include it in my quote. And I think if you think about how DFM works and constraints in geometry, like a lot of times when people say they need a part-shaped object, that's why 3D printing is so popular. Like they want to hold it up to the thing and see if it fits. And now they want to do it in metal. And it would literally be cheaper for everybody involved if they didn't spend time dimensioning it, making it a print, like get them a copy of the part and then they'll just order another one. And it's cheaper to order two with like whatever corrections they wanted for what they actually cared about than to try and force you to make a perfect part, right? So
yeah, we see that it's actually really common in sheet metal. My dog is breaking into the room. She knows how to open up doors.
Does she really?
Yeah, yeah. Wow. She can open up almost any door, and it's cute, and then it's really annoying. So now you have to pet her. With sheet metal, because it's inexpensive and because it's fast, we watch the version numbers of people's drawings, and you'll see it go from 0 to 1 to 10 to 38 or whatever. And they keep trying to move this thing around. And because it's inexpensive and because we can get it to them fast, they can make those iterations really quickly and then get to the final product where they'll run quantity or whatever. So yeah, 3D printing is a great analog to that in CNC machining. It's like, just print it, put it up to your thing. You're like, yeah, that's pretty close. Cool. Then just give me the model. If whatever you printed is going to be what I provide, as long as our spindle can reach it. So
machinists have this weird problem. A lot of times they get sent a part to make and you're staring at it on a screen, or you have a print, but it's on a screen and you have no concept of how big the part is in real life.
Yeah.
I don't know if that happens for sheet metal or not. But we added banana for scale into Toolpath, like as a joke for April 1st, but people were like, please put it back. Like this is actually extremely helpful for us.
Yeah. We actually make, these yellow powder coated bananas for scale. We have them as giveaways. We'll put them into packages every once in a while. We run into that all the time too, especially, when it comes to, it's one thing if you're the customer and you're like, I think this is how big it's going to be. It's another thing when you're the programmer, or, if you're ordering material or something and you're just looking at geometry and you don't realize that this thing is 9 feet long, or maybe it's like 9 millimeters or whatever. It's really difficult.
It's just 9.
Yeah. In the early days, we actually ran into a bunch of issues with unit conversion. And so millimeters versus inches or whatever. And I remember we had one of our guys on the floor. He was carrying this part and it was 10 feet long and it looked like this dog bone. And he goes, Jim, I don't know how we're going to ship this thing. And I was like, oh shit, what do we do? And it was supposed to be millimeters.
10 feet?
Oh yeah. Yeah. And that was the length of our sheet. So
please tell me that part is on a wall in here somewhere.
No, I think we had to cut a bunch of other parts. That was so early in our existence. We only had like 2 sheets of anything. So I remember chucking that thing back on the laser and we're trying to
make parts out of it.
Cut a bunch of other parts out of it. Yeah. No, scale's a hard one. I actually think that known objects like a banana, a coin, whatever is critical. And that's again, where 3D printers come out really, really cool to give you that concept. It's something that you can virtually hold in your hand. Or I have seen some cool stuff with like augmented reality, and there's some cool apps where you can, project it and gives you an idea. So
how would you feel about a SendCutSend Toolpath collaboration on a standard banana?
Yeah.
We should do that.
Yeah.
Put out a file.
Yeah. I was going to say not ISO, but yeah, we should make an SCS or SCSTP standard. Yeah.
There you go. Yeah. Standard banana. Wow. I think, yeah. So overall, if you are thinking about machining parts, what are the biggest differences you think between sheet metal? Like scale, obviously, material, but talk to me a little bit about what the roadmap, what the bumps in the road you already foresee are.
Setting expectation. So with sheet metal, you have a certain expectation because everyone's touched sheet metal, on their washing machine or whatever. And they know like, it can move a little bit, or, if it's out of whack, I can just bend it, So expectation for machining though is totally different. They're like, I want this thing to be perfect. It's got to
Jewelry,
look
yeah.
a certain way. You know, I've purchased these like billet brake levers for my motorcycle. And so if I order from SendCutSend, I want them to look just like that. And it's like, well, my toolpath might be different. My finish might be different, you know? So that's going to be a challenge there. It's just setting expectation. Luckily, a lot of our customers who are familiar with our brand already know, like, we're not this insane, you know, group of guys in lab coats that are going to provide these ultra perfect parts, but we will provide good parts really fast. So the expectation is already on my side a little bit.
Have you ever heard of the Tennessee floor finish?
No.
It's a pretty controversial topic on, the internets. But you can finish a floor using like a traditional pass, like a pocketing pass, where everything's like straight, same way you would on a Bridgeport by hand. But now you can also like use like an adaptive path to finish it. And I've heard some machinists that I trust say that that's actually like the technically superior way to finish a floor. Like it gives a flatter finish because the chip load on the tool is constant. But it makes these kind of like weird, swirly, like progressive things. It's called the Tennessee floor finish.
Okay. Why Tennessee? Do you know?
I do not know the
etymology?
History there, but it's derogatory. Yeah.
Okay.
Yeah.
Well, so our first test parts that we made, I looked at some of the tool pathing and it was adaptive or whatever. And I was like, oh, that's different than I would have done it on my Bridgeport. But I closed my eyes, and I run my fingers. I'm like, oh, it's totally fine. So, what we like to do is set expectations low and then beat them. So under promise, over deliver. So what we'll end up doing is all of our marketing documentation will have photos of, as low quality as we will tolerate, with the intent of beating it. So if someone comes onto our website and I'm like, hey, here's an expectation of your finish, here's what your part is going to look like. If they see that and they're cool with it, then we'll have a customer for life. If they see it and they're like, not good enough, that's totally fine. There's a bunch of other guys who can serve them. I just don't want to disappoint my customers. I want to knock their socks off.
So I got to handle some of the parts you're machining. And you have a really interesting tabbing method that's pretty cool. I think it's a nice way to tab things. But I remember at one point you said that you would ship the part with a bit of sandpaper for them to sand the tab off.
Yeah.
I so hope you do that.
Yeah.
I think that would be so like to offer a discount. Like we don't have to post finish this or anything. Just like the tabs are pretty small. And like there are customers who just wouldn't like, sure, I'll save $20. Like, yeah.
Well, yeah, I actually found a source for like really, really inexpensive files too.
Oh,
so
yeah.
I was like, oh man, I can just throw these files. They're like 60 cents each, and then, or the little emery board. No, it's because what we found in sheet metal is a lot of these parts are part of assemblies, or they're going to be welded, or, maybe they're just a mock-up, maybe they're just a prototype. No one really cares. So I think a lot of machinists struggle because they're like, oh my God, it has to look a certain way. I have to hold this standard. And then their customer is just like, oh, that looks nice. And then they just toss it on the floor and kick it around or weld it or whatever. And they never needed that level of care anyway. So we'll make sure that we offer a really good standard. And if they need it above and beyond, then of course we'll take care of them. But, our standard is going to meet a lot of people's needs.
Tim Paul, our chief customer officer, said that like the only good part's the part that meets the print, that meets the need. And he talks a lot about how Instagram has sucked a lot of profit out of the industry because everybody makes these like beautiful jewelry parts. And I'm not a great machinist, but like with modern tooling and any kind of reasonable machine, like on my brother, I can make mirror finishes. But when I've had trouble sometimes with chatter and I dial it back and the service finish requirement is like 128 RA or 32 RA. And I'm underneath that, but it doesn't look nice. I should have shipped that part. I shouldn't keep trying. Right.
Yeah. No, that's probably going to be our number one competition is Instagram.
Right.
And our customers are going to be like, oh, this looks like a beaver chewed it out of aluminum, with his teeth. Close your eyes, does it feel good? However, we are going to offer a bunch of different finishing options too. So our 360 micro finish offering is proprietary, but we're going to include that for free at the beginning and just be like, look, it's going to look good. Don't yell at me about my tool paths. I don't know what the hell is going on. We're just trying to get you a part, man.
Part-shaped object.
Yeah, part-shaped object, dude. So yeah.
I think that'll be really good for the industry as a whole. Like if you need that perfect part or like golf club putter or something, like people want that, like the cosmetics matter.
Totally.
Right?
Well, like we went to, we visited Area 419 the other day, and oh my God, their parts are gorgeous and they're retail ready. It's actually a level above that. It's like, you spend good money on a muzzle brake or something for a very expensive weapon. And you hold this thing in your hand and you're like, wow, that was made by a craftsman. It's really, really awesome. Our stuff is not going to be that. Like, it's just, we're not an OEM. I'm not targeting that type of market. I also believe that if you're going to make, design and sell a product, you should probably manufacture it. And 419 does a really good job of that. They design it, they make it in-house, they sell it. We always run into something, is a big part of like, people complain about American manufacturing. They're like, I can't find someone to manufacture my stuff. It's like, well, buy the machines, do it yourself. So we're here in that middle area where maybe they haven't graduated to purchasing a machine. So yeah, purchase parts from us, do some finishing to get it up to your retail spec. Like if it's a putter, I'll give you it. It'll be in tolerance. It'll have a good finish on it, a closed eyes finish. But if you need to media blast it, or maybe you need to, anodize it in your special color or something, then that's on you. And I think that'll be okay.
I have a suspicion that putters will be a little too much surfacing for you to start with, but we'll see. Maybe somebody will design a blocky putter.
Please don't send me any putters. Yeah. Or give me the Minecraft equivalent.
Right. Yeah. Except too many right angles on Minecraft parts.
Yeah.
Careful what you ask for.
Yeah. True.
I have a machinist friend who said that the fillet button is the most expensive button in CAD. Both external fillets on the outside of a part and then also like internal fillets.
But it's so nice to do.
It looks so nice.
It's so nice to do when it's on screen. Yeah.
Yeah. And the irony there is that so many engineers have been yelled at about sharp corners, and it's like, just make sure you fillet all your sharp corners. So then they go fillet. Yeah. Well, then you're like, I didn't mean those sharp corners, right?
Yeah.
So I'll be very interested to see how that shapes out. I think one of the advantages that you guys have is that you're planning to be very, very rigid on your tool list. So like it'll either, yes, we can make it, or no, we can't. And hopefully Toolpath can help you like in that gray area of like, okay, we're going to make it, but with these deviations. And like, are you cool with that? Do you want your part in 2 days? Or do you need the fillets, right? Maybe it's a stress problem, or you care about the fillets and then it's not a good fit. But I think that's a really unique thing that I appreciate, to be honest, mainly because it makes my job easier. But that you guys are planning to hold the line. Like you're not ordering custom tools for anybody's parts, right?
No, not at all. The In-N-Out example is what we live and die by. You go to In-N-Out and there's a hamburger and a cheeseburger. Get out. If you want weird, loaded tater tots and a fillet of fish, you just don't get to choose that. You don't get to say like, I want this medium rare.
I was in a meeting where you asked your machinist if you could have 20 XD tools, though.
Okay, well, I just wasn't sure if that existed. Or we need to develop them. Yeah, we need to get into material science for the next 2 decades. But what I want to do with that rigid, tool list and where we hold the line is we don't just say no. We say no with a why.
Right.
And that's where Toolpath is really interesting, when you can show these areas. It's like, hey, there's this weird, sharp wall on a pocket or something. If we can show that to the customer and be like, this is not going to look exactly like this. It's going to have some radius. Are you cool with that? If they're not cool with it, go back to the drawing board, and upload something else. Like, we haven't made it. There's no money exchanged. But that education is going to make them better and better and better. So I'm hoping after, a few orders, they're a pro. And then they're also going to be a pro in their career. We have a lot of young engineers that are new graduates or whatever that started using SendCutSend for sheet metal. And now I think they can carry those skills, with them for decades, whether we're around or not. So I want to do the same thing in machining. And, if they do have something that's really advanced and it does need custom tools, at least they understand why. They can have that communication with, a different shop to get those parts made.
Let's talk about quantity a little bit. I know on the sheet metal side, you do anything from like a one-off to like huge production runs, right? Is there a limit to that on the sheet metal side? Like you'll stop at some number, or?
No, No, we've done hundreds and hundreds of thousands of parts. We've had parts that run for months. We have a new job that we're actually looking at right now, and we're going to dedicate equipment to it. So yeah, there's no real like upper end for quantity. And it's because in sheet, you can produce a lot of quantity really quickly. And if you need, let's say a machine can produce 1,000 parts per hour. If you need more than that, you add another machine. Now you have 2,000 parts per hour. In order to do that with machining, you need 2,000 machines. It's crazy. So yeah, the quantity thing is going to be a challenge.
Well, you have a stock challenge too, because I think you're planning to hold like a small number of fixed size stocks, and you'll just make your parts out of that, right? Which
correct.
You can get away with an aluminum, and you'll just machine away the material you don't need. But at like larger production sizes, that really hurts your scale. Whereas on sheet, you just nest them, and like your efficiency doesn't change all that much, right?
Yep.
I mean, based on the shape of the part, it can change, but other than that,
yeah. Well, we do have a saw now, so the idea is for like quantity 1 and 2 to use this like container model, or this if it fits, it ships. Okay. So if I can shove that model into that cube, then we're good to go. I need to save on programming time versus machine time.
Right.
That's where I'm constrained right now. As we go into larger quantity and then our lead times are extended a little bit, we can invest a little more time into, manual programming and manual thought process in order to say, okay, actually, if I saw cut, all these things, or if I put them on a tombstone or whatever, then maybe we can be more efficient with that quantity. But a lot of the stuff that we're going to get is going to be low quantity. But I want to be able to handle the large quantities too. So.
I think you'll have an interesting challenge on your hands there. It'll be very interesting. Also, your waste will be a lot fluffier than you're used to.
Yes.
I'm waiting to see you get a chip briquetter. You're probably one of the few places that could actually like profitably invest in one.
Yeah. Well, I'm learning more about machining all the time. 6 months ago, I was like, okay, not only are we going to get chip briquetters, but I'm also going to get a forge, and we're going to remelt it, and we're going to cast ingots, which is not the same as billet, but then we'll offer it as like, aluminum-SCS. It's like, hey, it's a cast equivalent. It's kind of shitty, but if you need a little brag for something, maybe we can do that. Everyone slapped me and was like, please, for the love of God, don't do that right now. It's going to be a huge distraction, but it's still in the back of my mind. I was like, I think I can take my waste and then remelt it, because we have a decent amount of scrap from the sheet metal operation too, which would be interesting. But yes, much fluffier waste than we're used to.
I think, don't hold me to this. I think a while back I heard that ThyssenKrupp was doing a thing where they would, basically you could order laser cut or water jet cut parts. And it was like cheaper for them to give you the near net because they could control the scrap, which meant they could remelt it and guarantee composition and everything.
Oh yeah, that's awesome.
So that because if you lose traceability on that, now you don't know if it's 60-61 or 70-75, or if there's a little bit of steel mixed in or somebody dropped a penny in there or whatever.
Well, like in powder coating, there's a color called floor sweep.
Really?
And yeah, so that's just like whatever. It's just you sweep it all up.
Wait, is that on the website?
No, that's super secret, man.
Okay. The next thing I order is floor sweep.
I'll hook you up with floor sweep. What happens? Floor sweep actually comes out to be this like really cool root beer brown sometimes.
Yeah.
If you're really lucky. Sometimes it just flakes off and
it's no good.
Causes us issues. But this would be the metallic equivalent of floor sweep. Yeah.
Like it's maybe brass or aluminum or a little bit of both. We don't really know.
Yeah, don't worry about it. It's metal.
That'd be really cool. I think long down the road, because your volume is so high, your stock prices are so much like when I'm doing quick turn stuff, I order from McMaster, right? And so I'm paying like the tippity top price for stock.
That's wild. Yeah.
And there's a lot of shops that do that just to get turnaround time. There may be a world in which you're able to partner with shops and like, Al Watmo suggested this. This is very far down the road, but since we're just riffing now, like you might just rough it to near net shape.
Yep.
And then like, cause the stock is cheaper, costs you almost no programming time, saved you on shipping. And then you ship that to somebody else to do like the finished high precision features or like get the good finish or whatever.
Yeah, totally. We'll be op zero.
Right.
Or something like that. And I think that makes a lot of sense because it leverages our strengths and allows, all these super talented machinists to do what they do best. And, I don't want to do some of the crazy stuff that these guys do. I don't have 2 decades to get good at it. And, I'm not here to disrupt that market. I'm here to, make it more accessible to like high school kids who are building, a first robotics competition bot or something like that. I want to give them cheap parts that are going to be part-shaped object, and then we're good to go.
I actually think FIRST Robotics is going to be like, I think it's an underutilized resource right now. I have to figure out how to get my son interested in it. I haven't succeeded yet. He has loaded parts for me. But like the need to make something so that your robot can survive is like what I think will drive like a passion for joining the industry.
Yeah.
And a lot of other podcasts I've heard or been on, people like, how do we get people to join the industry? And my brain always goes to like, when they need something made so that their bot can destroy somebody else's bot or can like win the game or whatever. BattleBots is another good one. I feel like we as a community need to find a way to invest in and like sponsor those events and make them more popular. It's a personal goal of mine to figure out how to help with that going forward.
I feel like video games stole a lot of those activities. It's so easy to jump on and start playing a video game. Because I'm older, we didn't have video. Well, we had like Mario, but my pastime was, trying to build go-karts out of old lawnmowers, or whatever we had in the shed, or building model rockets or whatever. So my needs for fabrication and machining and stuff like started at a very early age. My son is 15 and I'm like, dude, you have millions of dollars of equipment here at your fingertips. You can build anything you want. And it's really a challenge, for him to do that. So yeah, I feel your pain. But things like FIRST or things like Formula Baja, Formula SAE, I think more kids are being exposed at the college level now. Mm-hmm. And that's really interesting. There's a lot of activity and interest in aerospace now, because of SpaceX and all these different launch companies. It's really cool. So, I think it's turning a little bit. It's not as bad as it was 10 years ago. And I think in 10 years, it'll be, there'll be way more interest.
Race car team was how I found manufacturing. And I like to say where I became a good engineer. But it was a $2,000 grassroots motorsports challenge.
Oh, so yeah. Hell yeah.
Yeah. And so my first car was in the gravel on an 85 Volkswagen GTI. Yeah.
Okay.
I never want to see one of those again, but but it was a good car to work on. Let's talk a little bit about how you view your role in the machining community. You've told me some of that. I'd like to give you a chance to talk through that and how you want to support the broader community.
Yeah. When we first started, mentioning that maybe we're going to get into CNC machining, I got some private messages where people are like, "Oh shit, you're gonna run me out of business." And I was like, "No. We didn't do that in sheet metal. We're not planning on doing that in machining either. We're planning on, hopefully creating a larger market. We want to make the pie bigger. So I'm hoping that we can offload some of the garbage, like the onesie twosie weird stuff, all the customer education. I want to offload that from really good shops because we can handle it. We can handle it in scale. We have a great team. We have great software, great machines. And we have the patience to hold someone's hand and say, hey, we can't manufacture this design, but here's the modifications you could make in order to do it. And I'll do my, quantity one or whatever. I'm hoping that if they get that first time experience with SendCutSend, and they get a few parts under their belt, then yeah, if they want to go more advanced, it'll actually help the machining community because we're going to hold that line. They're going to be like, hey, I need this, tangerine anodized, and it's got to be this weird, alloy that I've never heard of and we don't stock, or, it needs that 20XD drill or something like that. Be like, cool. Tell you what, here's a list of partners that we recommend, or, maybe we even sort it by zip code or something like, hey, here's 5 guys in your area who are going to be badass. We can't do it for you, but we trust these guys. So building that referral network is going to be really important for us. We've already started on that. Does that answer your question? I
think so. Yeah. Okay. I think there may be a secondary flow of this. I'll be interested to see, but I've talked to a number of machinists who get that one part from their customer that they either don't want to make or they're too busy to make. Yeah. It's not a super hard part. It's not a high dollar, high value part. And that's really challenging because it's a great customer and they don't want to say no to them. And they also don't want to like lose the customer. So they don't want to just push them off and be like, just send that one to SendCutSend. So I wonder if you'll end up getting like, I'm sure this happens in sheet metal, but like subcontracted parts out. And if you can do a good enough job, or if they feel like they can clean it up or maybe do some secondary finishing on it or something, that you'll end up being a support system for shops when there's like, because nothing is worse than like accepting a $200 job because you don't want to upset your good customer and then having to turn down a $2,000 job because you don't have the capacity for it.
So that happens with us in sheet all the time. Like some of our best customers are what you would consider a competing sheet metal shop. And it's because like they don't want to look at anything if it's below $2,000.
Right.
It just doesn't make any sense. They're measured, they measure their customers in the tens, not the tens of thousands. So they don't have time to bid on something unless it's going to be worth it. So oftentimes they will just place that order. We will ship it to them. They'll rip it out of the packaging, and then resell it. And oftentimes it's profitable for them. I think we'll see the same thing in CNC machining. So we do have a white label product too, where we'll ship it in blind packaging. So a lot of times we can just drop ship it to the end customer. And even with our marketplace product, marketplace is way like if you're a designer and
I have to upload something to that. Thank you for reminding me.
Okay. Yeah. Go for it. If you're a designer and you have an idea, you can, we force you to order one. Mm-hmm. We want you to hold it in your hand before you can start selling it to other people. Once it passes that test, you can put it into our marketplace. And then we're like, hey, here's how much it's going to cost. How much do you want to sell it for? And you get to keep the delta. So we have guys we have one guy, I think he went to Cancun because on his marketplace money. He's like, hell yeah. My goal is I want to see a picture of a guy in his new truck that got paid for by marketplace. But we're like that concept is
when that happens, Toolpath will cover the banana for scale wrap that we put on the truck.
Yeah. The marketplace concept is good. It started out in sheet metal. It allowed us to get our feet wet, but sheet metal is limited. Like there's only so many things you can make in sheet metal that are like a retail product. We make a lot of skid plates. Like that's actually one of the best things. A lot of RC car parts too. But then adding in CNC machining, that's where it gets really interesting. So we're hoping that people build these like little boutique industries, based on marketplace. It's like an Etsy seller type thing. And then some of those people will end up being machine shops too, or they'll order in quantity. We'll either drop ship it to their customer or drop ship it to their warehouse, and they can resell it. Yeah. So I think we can absorb a lot of like the bad jobs that people don't want, and it's what we're used to.
Well, I'll tell you what, I'm really looking forward to the 24/7 live feed of all your mams running nonstop. So that'll be like what I have on my shop TV real soon, hopefully.
Yeah, I think we need like the beep button, on TV when someone says a bad word and it has the
We'll just
delay.
do no audio.
Yeah, it's like when the machine crashes, you're just like, oh God, don't show that. Or actually maybe that's a highlights reel. I don't know.
I think that's when the views will spike.
Yeah.
Look how close they're getting to the trunnion. Yeah.
Yeah.
Also, you'll have to start cutting dry just to up so.
Yeah, I heard that's not good. So
you can do it in aluminum for a little while. But maybe you just have to switch to steel for like a day or something.
Okay. Well, I think we bought those super fancy cameras with the little spinny thing.
That helps. Yeah.
I don't know if it'll be.
But sometimes the coolant's like all up in your business, and you just can't see what's going on.
Yeah.
But you'll get real close to the trunnion at some point. I know you guys are setting up Camplete for like verification and everything, so that'll give you the confidence to slam right into the trunnion at full speed. It'll be great. Yeah.
Okay. Yeah. It's not a matter of if, it's when. So.
Yeah. I think Tim Paul's the only machinist I know that says he hasn't crashed, or he's only crashed once, I think. But I've crashed plenty of times. I'm not proud of it, but I'm not afraid to admit it either.
Yeah. Well, I'm hoping we get some of that out of our system on the Haas instead of on the MAMs.
Yeah. Well, Jim, I really appreciate your time. I'm going to give you the last word here.
Oh, is this tradition? I don't know what my last word is. I wasn't prepared for this.
You weren't prepared for it?
No, this has been awesome. I guess my last word would be reach out to me. Reach out to me on X. I'm just Jim Belosic, or on Instagram, I'm Jim Belosic. Tell me where this is going to break. Tell me where it's going to be successful. Tell me what you're excited about. Tell me what you're worried about. I'm going into this pretty blind, but I have a great team, but I don't know what I don't know. So if you guys have tips and tricks, please reach out. I'm all ears. I'm here to support the community and hopefully be an upstanding member of it.
All right. Well, thanks, Jim. And don't forget to tune into the 24-hour live stream of the MAMs.
I'll work on that. Yeah. Thanks for having me.
All right. Bye.